Okay, let's continue looking at limits on our new worksheet today. Now, the front page is all about evaluating each limit at the given point for the given function. Now, the first one, really easy. It says the limit is x approaches -1 of 5. Well, the function is 5, which means everywhere here on this function, the limit is going to be 5 because, well, that's what the function is. So for the first one, our answer is 5. Let's move to the second one. The limit as x approaches -5 halves of -x plus 2. All right, so what we're going to do is plug in. This is one of the easiest ways to evaluate limits, is just plug it in. Okay, so we have -5 halves, but we have this negative side out front. Those two cancel each other. So we have 5 halves plus 2. Now, 2 in the in twos would be 4 over 2. So we have 5 halves plus 4 halves, which gives us 9 halves. And that's a good answer. All right, let's look at the next one. Number 3. Limit as x approaches 2 of x to the third minus x squared minus 4. We're just going to plug in 2 to the third minus 2 squared minus 4. This is 8 minus 4 minus 4. The limit at that point would be 0. Okay, number 4. We're going to plug in 1 for all our x's. So we have -1 squared over 2 plus 2 times 1 plus 4. Okay, well, this is just 1/2. And then we have 2 plus 4, which is 6. So we'll have 6 minus 1/2. Really, this is -1/2 plus 6. So 6 minus 1/2, which I guess we could say 5.5, or how about 11 over 2? Okay. So that's really all you're doing on the front page. Just plug it in and see what you get. Now, the second page is we're going to look at some graphs again. And this is really where our ability to find limits is important whenever we're looking at graphs. So let's look at the first one. The limit as x approaches -1 from the positive side of this function, 4x plus 4 over the absolute value of x plus 1. Okay, so here's what happens. As x approaches from the positive side to -1, the function stops right here. And this y value is +4. So this limit would be +4, which differs from if the question would have said, what is the limit at x equal -1? Now, since the function -1 is basically non-existent because these points aren't in the graph, well, we wouldn't have a limit there. But we're talking about as x approaches from the right, we would be at +4. Now, let's say x approached from the left, from the negative side, our limit would be down here at -4. Okay, let's look at graph 2. In graph 2, we're trying to see what happens as x approaches -1 from the negative side or the left side of this piecewise function. So here's the left side of my graph, and as you can see, it runs in until we get to -1, which is what we're looking at as far as our domain value. Now, what happens to the range there? Well, the range looks like it stops at -7. So the limit of that function as it approaches -1 from the left, -7. Okay, let's try number 3. Let's see what the limit is as x approaches -3, and it doesn't say from the left or the right, of f of x for this piecewise function. So all we're looking for is, what is really the value of this function at x at -3? We're trying to see if it exists. And it looks like if we plug in a -3, we would be right here. And the value there for the range is -3. So the limit at x as x approaches -3 is -3. Okay, finally, last one on the front. The limit at as x approaches -1, the limit as x approaches -1 doesn't say from the left, doesn't say from the right, just at this point of this piecewise function. Well, here's the thing. At -1, the function is equal to a few different things, and the limit is different if you approach from the left or if you approach from the right. So right at the point -1, we say the limit does not exist because we have a disjoint in our graph right there. Okay? Now, what I want you to try to do is flip this page over. Back here, there are a few graphs. Here they are. Try to find the limits of these. Sketch the graph real quick, which will give us practice working with piecewise graphs because we're not too strong with those yet. And down here, we have a few other functions. See if you can find the limits of these. And then we will go over this the next time we have class.